Greetings from planet Earth. Welcome. This is the planet Earth, and if we step slightly outside the atmosphere, we will find the solar system, which consists of the Sun, planets, moons, asteroids, comets, and other celestial bodies. The Sun is a star that lies at the center of this system, and its gravitational pull keeps these objects in orbit. The solar system is located in a small region of the universe within a spiral galaxy known as the Milky Way. The Milky Way galaxy contains hundreds of billions of stars and their respective planetary systems. Surrounding the Milky Way are satellite galaxies such as the Large and Small Magellanic Clouds. Together with around 50 to 80 other galaxies, including the Andromeda Galaxy, they form what is known as the Local Group, which spans a region of space about 10 million light-years across. A light-year is a unit of distance that measures how far light travels in 1 year. Since light moves at approximately 299,792 kilometers per second, or about 300,000 kilometers per second, 1 light-year is roughly 9.46 trillion kilometers. This immense distance emphasizes the vast scale of the universe. The local group exists within a larger structure called the Virgo Supercluster, which spans about 110 million light-years. It contains thousands of galaxies and multiple smaller clusters, including the local group. Previously, astronomers believed that the Virgo Supercluster was the largest cosmic structure. However, research in 2014 revealed the existence of an even more massive structure called Laniakea, a Hawaiian term meaning, immeasurable heavens. The Laniakea Supercluster is a vast network of galaxies spanning approximately 520 million light-years, and it is the gravitational center that pulls our local group and neighboring clusters toward it. In 2014, a team of researchers led by Brent Tully from the University of Hawaii mapped the motion of over 8,000 galaxies and found that they were all moving toward a gravitational center. This discovery helped redefine our understanding of galactic structures, showing that galaxies are not randomly distributed but are instead connected in a cosmic web of filaments and voids. The Laniakea Supercluster is part of this web and represents a major gravitational anchor for many galactic clusters. According to modern cosmological models, the universe's large-scale structure can be visualized as a cosmic web, somewhat analogous to a neural network in the brain. In this analogy, each galaxy cluster or supercluster represents a node in the web, connected to others by vast filaments of dark matter and intergalactic gas. While the brain's neural cells are individual entities that communicate through synapses, the universe's large-scale structures are interconnected by gravitational forces. When researchers mapped the Laniakea Supercluster, which includes our galaxy, they discovered that it spans approximately 520 million light-years and contains around 100,000 galaxies. This supercluster redefined our understanding of the universe's structure, showing that galaxies are not randomly scattered but are part of an interconnected network influenced by gravitational pull. The Laniakea Supercluster has 4 main branches, or galactic clusters. First is the Virgo Cluster, the most significant branch, containing the Milky Way galaxy and thousands of other galaxies. Second is the Hydra-Centaurus cluster, another prominent structure within Laniakea. Third is the Pavo-Indus cluster, located in the southern hemisphere of the sky. And fourth is the Southern Supercluster, composed of smaller galaxy groups. These clusters form the backbone of the Laniakea Supercluster, with numerous smaller subclusters and galaxy groups interwoven throughout. Surrounding Laniakea are neighboring superclusters, such as the Shapley Supercluster, one of the largest known galaxy superclusters. The Hercules Supercluster, another dense region of galaxies. The Coma Cluster, a well-studied cluster of galaxies. The Perseus-Pisces Supercluster, a prominent chain of galaxies stretching across a vast distance. The mapping of these superclusters was a significant challenge due to the overlapping boundaries between them. Galaxies within these clusters are densely packed and gravitationally interacting, making it difficult to determine their precise groupings. However, researchers identified a massive gravitational anomaly known as the Great Attractor at the center of the Laniakea Supercluster. The Great Attractor exerts a powerful gravitational pull, causing galaxies from surrounding clusters to move toward its center at speeds of over 600 kilometers per second. This gravitational anomaly is not a single object but rather a dense region with a high concentration of galaxies, dark matter, and possibly supermassive black holes. The outer regions of Laniakea contain fewer galaxies, while the central regions near the Great Attractor have a much higher density of galaxies and dark matter, making it the gravitational focal point of the entire supercluster. Imagine you're aboard a futuristic spacecraft, gliding through the boundless depths of the universe. Stars shimmer like cosmic jewels, galaxies whirl in their endless dance, and you begin to wonder, what invisible forces are at play in shaping this magnificent expanse? The answer lies in a cosmic tug-of-war between gravity and dark energy, a struggle that determines the fate of galaxies, including our own Milky Way. In one corner of this cosmic battle stands gravity, the invisible force that draws masses toward each other. It's the glue that binds stars into galaxies and galaxies into clusters. In the opposite corner is cosmic expansion, driven by the mysterious force we call dark energy, which relentlessly pushes galaxies apart. In our local region of space, gravity holds the upper hand. Take the Milky Way and its neighbor, Andromeda. These two colossal galaxies are on a collision course, pulled together by gravity at a staggering speed of 110 kilometers per second. In around 4.5 billion years, they will merge, forming a giant elliptical galaxy often referred to as Milkomeda. But venture farther into the cosmos, and the balance shifts. As distances increase, Hubble's law takes over, revealing that galaxies farther away are speeding off into the distance, carried by the fabric of space itself. A distant galaxy in Cassiopeia, like NGC 1855, is hurtling away from us, its motion driven not by its own propulsion, but by the expansion of space. At 10 million light-years away, a galaxy would typically be receding at a speed proportional to the Hubble constant, about 70 kilometers per second per megaparsec. Yet, not everything in the universe is moving apart. Deep within the Laniakea supercluster, an invisible force is pulling galaxies inward. This mysterious region, known as the Great Attractor, is a gravitational anomaly, a dense collection of galaxies, dark matter, and possibly supermassive black holes, with enough mass to counteract cosmic expansion on a local scale. But what exactly is the Great Attractor? Unlike a single massive object, it's a vast, complex structure made up of thousands of galaxies bound together by gravity. Recent studies suggest it may be part of an even larger formation, the Shapley Supercluster, one of the most massive known galaxy concentrations in the nearby universe. Despite our best efforts, the true nature of the Great Attractor remains elusive. It lies in a region of space obscured by the zone of avoidance, where thick clouds of gas and dust in our own galaxy block our view. Yet, its gravitational influence is undeniable. The Milky Way, along with countless other galaxies, is being pulled toward it. The universe is a story in motion, a tale of galaxies colliding, expanding, and being drawn into mysterious gravitational wells. The Great Attractor is a key chapter in this cosmic narrative, a reminder that even in a universe driven by expansion, there are pockets of gravitational power strong enough to resist. As our understanding of the cosmos deepens, we are reminded that we are part of an ongoing journey through the fabric of space and time. With every new discovery, the mystery of the universe grows richer, beckoning us to keep exploring, to seek answers, and to marvel at the unseen forces shaping our destiny. And this is the end. Don't forget to share your thoughts in the comments. To the next video, be curious.